Hi, my name is Stephen Roth, and today I will be presenting our load calc app called HVAC ResLoad-J. And it's an app that performs peak cooling and heating loads for residential and light commercial facilities based upon the ACCA Manual J8 handbook. So today I will be demoing this app for you and showing you how it works. Now this is an iPad app, and it works only on the iPad. And what you see on your screen here is actually what's called an emulator that is running on my MacBook. And it looks exactly like what it would look like on your iPad. And it's a great way to do training and webinars like this, and also for testing our software. Now you can use this app either in portrait or landscape mode. I will be demoing it today in landscape just because it's more conducive in that mode. However, the inputs are all the same no matter what. They're just laid out a little differently. All right, looks like we have an additional person joining us. I will wait until they are fully online. So can you all hear me? All right, I'll continue, and if you want to chime in at any time, feel free to do that. Randall, looks like you just joined us, so feel free to chime in at any time with questions. But I will be demoing the HVAC ResLoad-J app today, showing you how to use it. And like I said, at any time, if you have any specific questions, feel free to ask. We have a small audience today, so it should go relatively quickly. All right, so I'll continue with the demo. And as I mentioned, this demo is being recorded, and I will be posting it on our website at a later date. All right, so when you first start the app, and as I mentioned, we're using it in landscape mode, you'll see this screen here. And on the left, you see a list of all your projects. And a project, it can be a house, it can be a light commercial facility, or if you have a really large house, it could be just one system in that house if you want to break it up into multiple systems. Kind of like what we did with the Ross residence here. We had system 1 and system 2-3. And to create new projects, all you need to do is click the little plus button here, and up pops a form. And you can type in a new project name and click save, and it will create a template project with very basic information. However, better yet, you can actually copy from an existing project, and that's what a lot of people do. So if you click this, you'll see that it will list all of your projects. You select the one project you want to copy from and type in the name, click save, and it will actually create a new project based upon your existing project with all the same data. So this is a great way where you can create templates, and you can copy those templates over and over again. And it really saves a lot of time because you don't have to retype and re-enter all that information over and over again. Just for the sake of time, I'm going to look at an existing project. I'm not creating a new project today. But you'll see a common theme throughout the app. Anytime you want to create something new, whether it's a new envelope, window, or skylight, you just click the plus button. And hello, Randall, can you hear me okay?
Yes, sir, I can.
Oh, great. Okay. I don't know if you heard me before, but feel free to ask questions at any time. It's a small audience today, so.
Sure. Yeah, actually my son's calling in too. I bought this for him. He works in my company, so he'll be on here in a second too.
Okay, great. Okay. So in the meantime, if you could just mute yourself while I'm talking, okay, because I am recording this. And then, yes, like I said, at any time, if you want to ask a question, just unmute, ask the question, and then I'll answer it.
Okay. Thank you, sir.
No problem. Thank you. All right. So I will continue. So here we have existing projects. I'm going to select an existing project for our demo today. And as I mentioned, on the left is your project list, and on the right are the inputs associated with your project. And a lot of people don't realize this, but there's actually more inputs than just what's on the screen. You can swipe with your finger, in this case my mouse because I'm on my emulator, and you'll see there's more inputs. And then swipe again, and there's outputs. So you can see that, and this is a common theme throughout the app, you see little dots at the bottom. That means you can swipe to different screens. So here are some basic project inputs where you enter your basic address and project name. Probably the most important input here is your city. So if you click this little caret icon there, it pops up a form that allows you to select your state and city here in the US, and it will autofill in weather data based upon ASHRAE and ACCA data. Now, at any time, you can override this data if you want. Also, you can map it. What map it does is it will actually zoom in on your location and find the closest weather station that's in the database, which is indicated by a pop. And then it will automatically select the data for you. It'll select the city that's closest to you for you, so you can use the map it functionality. All right, so I'm going to close that. And then down here at the bottom, you can start entering your total floor area. Now, you'll see a common theme throughout the app is you can either enter data directly into a text box. So if I, put my cursor in there and let me actually turn on the keyboard, okay? And I can actually type in values. So I'll type in 3,600. I can also slide the slider. And as you can see, it increases and decreases the value. So there's, a couple different ways you can enter certain values. Now you'll see in this case, it looks like these two sliders are in tandem. And the reason is most of the time you're going to heat the same area of the building or home that you're going to cool. So they slide in tandem. Now there happens to be a different square area that you want to heat. Just go into this input and override it. If I want to override it to say 5,000, I can do that. And you'll see now that the number has turned from maroon to black. So any maroon number means that it's a derived number, and somehow it's affected by some other input. In this case, though, now that it's black, it's on its own. So as I move it, you'll see now they're not in tandem. To get them back in tandem, just go back, erase the number, click done, and now you'll see they're in tandem again. So you'll see that there's certain inputs that have this behavior throughout the app, and that's why we see these numbers that are in maroon. Down here, I can enter my average room height, and what it does is it calculates my total volume of my building, and volume of your building or home is required to calculate ventilation and infiltration rates and loads. Here I can enter the number of bedrooms, and then based on the number of bedrooms, it adds 1 to it to get the number of occupants. So for example, if I have a 4-bedroom home, you'll see it automatically ups it to 5 occupants. And occupant loads are taken into account for both sensible and latent heat. Okay, down here you have your appliance load. So you can either select low, medium, or high. Low is 1,200 BTU per hour, medium 24, high is 34. Pretty straightforward. Custom, however, is a little bit more customizable. So if you select custom and click the caret down here, it opens a form now where you can start adding your own appliances, and it will autofill in the sensible and or latent components due to those appliances. So let's look at an example. Click the plus button here and click the little caret. And now let's say I want to add a dishwasher that's in my kitchen. Okay, I have one dishwasher. The dishwasher adds a sensible load of about 4,000 BTU per hour, latent about 1,400. Average in-use output, usually leave it 100%. Percent use per hour. Obviously, you don't use a dishwasher 100% of the time. Use it, minimal part of your time. So you enter the percentage of time per day that's used. Even 25% sounds a little large, but we'll leave it there. But you'll see that the sensible and latent components for this dishwasher are 1,000 and 358 after we multiply out these values by 5.25. So now it's added to my list. I'm going to click another appliance. Let's add a television, color television. And let's say we have 3 of those in our house. And as you can see here, there's a sensible component of 683 BTU per hour. Percent used per hour, 100%. Well, maybe some homes have the TV on 100%, but let's go down to 50%. And you'll see now that it multiplies everything out, and your total sensible load due to your televisions is 1,000 BTU per hour. And I'll add one more item. Obviously, most homes have many more items than just these, but just for the sake of time. All right, let's add a computer. And a lot of homes these days have multiple computers. Let's say we have 4 computers, 1,500 BTU per hour sensible load. Let's say that the percent used per hour is about 40%. So we have 860 BTU per hour for our computer. So here we have 3 appliances. We click done, and it fills it in the total here. So our total appliance load is 5,600 BTU per hour. And you'll see later on in the room-by-room mode of this app, you'll be able to assign those specific appliances to individual rooms. Now, one thing I failed to mention is currently we are working on the block load portion of the app. So what does that mean? Basically, we're looking at the home as a whole unit. We're not looking at the rooms yet. We start out with looking at the home as one big unit, as one big block, so we can size our equipment. And after we do that, then we're going to do our room by room. So then we can start determining airflows and loads for each of the specific rooms. So we start out with the block load, then go to the room by room. Now this may be different than other load calc apps that you're used to, more desktop apps out there. They start out with the room by room, then they do the block load. The reason we do the opposite is because you're using this app out in the field, and you quickly want to be able to size equipment. So the best way to do that is to first do the block load. That's the easiest, fastest way to do it. So that's why we do it that way. But you'll see how the two work together a bit. All right, so we're in our block load mode. We're looking at our project information. So let's swipe. Oh, actually, before I do that, let me show you this. So you'll see here there's a pie chart with a breakdown of my cooling load. So what's nice about this is you can instantly see what your load is, your total cooling load and your airflow, and also a breakdown. And you can visually see it in this pie chart. And this is for cooling. If I click heating, you'll see the same for heating. Then AED curve. So what is the AED curve? Let me click the little calculator icon there. AED curve is required by ACCA for this to be an approved app. And AED stands for Adequate Excursion Diversity. And basically what it means is, how is my load, specifically my fenestration or my window load, changing throughout the day? So you'll see at 8 a.m., my window load is around 6,200. And as the day progresses, it peaks around 2 o'clock, and then it falls off, which totally makes sense, right? So this shows you kind of an hour-by-hour load profile. And the reason we want to look at this is you'll see this yellowish line up here. If this curve at any time goes above that yellow line, that means you probably need a VAV system in that home because there's just too much diversity, okay? However, if you're below this yellow line, then you're probably okay with a constant volume system in your home. So it's important to look at this, and this is why ACCA requires ACCA-approved apps to have this, because it's important to be able to specify the correct type of equipment for your home, whether it's a constant volume or a VAV. And what you'll also see this for individual rooms, which I'll show you in a bit. And it's really cool to see how different rooms, depending upon whether you're on your east, west, south, or north-facing areas of your home, how their AED curves vary quite widely. All right, so let's move on. And swipe. And just as a note, I noticed someone else just joined us. I think it's your son, Randall. Feel free, Reese, if you want to ask questions at any time, just unmute yourself and you can ask a question and then just mute yourself again after you ask your question. I just want to make sure we don't hear any background noise while this demo is going on. So feel free to ask questions at any time. All right, so now we're on to our next screen here for our project. And here we can specify our cooling set point, our heating set point, our humidity. Once again, you can either enter the value using the keyboard, or you can also use the slider. And what's cool about the slider is as you move the slider, especially for cooling, you see how it changes my load on the right-hand side here. Same thing for heating. But as I change my indoor heating set point, you'll see how it's changing my heating load. And what's interesting about this, you'll notice that the pie chart isn't changing at all because everything is moving in proportion. For my cooling, the pie chart was changing. It's kind of interesting how to see, as you move that slider, how your loads change and how also your relative loads change to one another. And then relative humidity. So relative humidity won't affect your heating, but it will affect your cooling, specifically your ventilation and your duct flow heating. Down here, I can enter my cooling supply air temp. That's the temperature of the air coming off my coil. Now, we get a lot of calls about this. We get calls saying, hey, you know what, my CFM seems too low, or hey, my CFM seems too high. Well, remember, CFM is calculated based upon your total cooling load divided by your factor of about 1.1, depending upon your elevation, times your delta T. Delta T includes your indoor cooling temp set point minus your cooling set point. So if you have a very large delta T, that means that your airflow is going to be fairly low. So let me show you this. So as I decrease my indoor cooling set point, look at how my airflow is increasing. Or let me decrease my supply air temperature to 50 degrees. And let's see how the airflow changes from 1800 to now 1300. What's happened is my delta T increased, and as a result, my airflow decreased. So people, say, hey, you know what? I thought CFM should be 400 CFM per ton or whatever. It's not quite doing that. Well, what you need to do is you need to kind of play with your set points a little bit, either your cooling supply air temp or your indoor cooling set point. We get calls about this at least once a week about this. And, this old rule of thumb of 400 CFM per ton is probably not valid these days, especially with, high efficiency type units being installed. The rule of thumb values are really antiquated. All right, so in here you can enter your supply heating air temp, usually around 120 in your furnace. Okay, let's move down here to additional inputs. So these are pretty important here. Construction tightness, select the little caret, and you can select either tight, which means it's a more modern home, which has, a more tight and solid construction. If you're not sure what it is, just select average. And if it's an older home where it hasn't been upgraded, which still has single pane windows and leaky doorways, then you enter a loose construction. Now, the cooling infiltration method. Select that. So infiltration, as you probably know, is any air that comes in through your windows or your doors, especially in the winter. And if you have leaky windows, single pane windows, or doors which don't have good stripping at the bottom, you're going to have a lot of infiltration, and it's going to increase your load. In the winter, obviously, you can increase your heating load. In the summer, it's really hot out, it will increase your cooling load. Now, it's more of a problem in the winter because, usually it's windier out. So as a result, you have more pressure, actually a negative pressure in the home. So there's more air coming into the home. In the summer, it's not as big of a problem, but it still can be an issue. So there's a couple of different methods that ACCA suggests that you calculate the amount of air coming in through those leaky windows and leaky doors. And here's three methods: the Manual J air change per hour method, the lower door method, and the direct entry method. So I'm only going to talk about the first one. Lower door method is fairly complicated, more for people doing lower door air testing. And you can look in the ACCA Manual J handbook for definitions on all these items. Let's go to the Manual J air change per hour method. So what you do here is you select the number of exposures that your building has and what type. Is it a single-story home, two-story home, 3 or 4 exposures, or is it a townhouse? So just select the type of house that this best describes. And then the construction tightness we selected before. So based upon these two parameters, it will automatically calculate your air changes per hour and then your CFM, 152 CFM. So the way it gets this air change per hour, it takes that volume number. Remember, we selected the total. We selected the total floor area and also the average room height. It takes that volume, applies a bunch of calculations to it, and it calculates your total CFM. All right, and if you want to go to the direct entry method, this just allows you to brute force enter an air change number or a CFM number. So if you know for sure, somehow you know exactly how much CFM is coming into the filtration, you can enter that here. Let's stick with the Manual J air change method. All right, so that's for cooling. For heating, it's similar. The only difference is you have to add in fireplaces. because once again, because it's windier outside, usually in the winter, especially, you know, if you have a flue that's not, you know, super tight or that's always opening, you should take into account your chimney. So here you enter the number of fireplaces and also, you know, the construction tightness of that fireplace. And it will then calculate your infiltration during winter. And you'll see during winter, the CFM is higher than during the summer. So it takes those CFM values, performs calculations, and it calculates your infiltration load. In this case, it's a little over half a ton for cooling. And for heating, it's about pretty high there, 20,000 BTU per hour. So if you think those are too high, you can always lower those values. All right, just for the sake of time, I'm not going to go through all these inputs, but let's talk about ventilation. So ventilation is air that, you know, it's different than infiltration, right? Infiltration is air that's leaking into your home. Ventilation is outside air that you want to come into your home to freshen it up, right? To get that fresh air from the outside. And that usually comes in through your furnace. So ventilation, there's two methods here. You can do the calc vent rate, and what that does is you'll see that's a maroon number, that means it's calculated. And the calc vent rate, the program will automatically calculate your ventilation rate based upon a number of parameters, including the volume of your home, including if you have any infiltration, and also your exhaust. Because if you think about it, if you have infiltration coming in through your window and door, but then you have ventilation also, you know, there's going to be some positive pressure due to that infiltration. So not as much outdoor air will come in through your furnace. So it takes all those conditions into account and calculates your ventilation rate, which in this case is 132 CFM. It takes that number, plugs it in, and calculates your ventilation cooling load or heating load here, 8,800 or 8,600. Cooling load, a little over half a ton. Now, if you know for sure what your ventilation rate is coming in through your furnace, then select man vent rate, and you can enter a value here. Exhaust airflow, if you have any bathrooms or kitchen exhaust that runs fairly consistently, you can enter that. And as I mentioned before, you know, this number may affect your ventilation rate and also your infiltration rate. So the infiltration rate, ventilation rate, exhaust are all interrelated. They all affect one another. All right, let's talk about duct. So, you know, as you probably know, if you have a leaky duct system, you know, in your attic that's not well insulated, it could drastically affect your load. It could add tons and tons of cooling to your cooling load, because as that air is passing from your furnace to that leaky ductwork that's not insulated, you know, a lot of that air is going to escape into your attic and not go to where you intended to go. So there's a lot of waste. As a result, you really do need to properly model your duct system. Now, this is not a manual D software tool. This allows you to approximately model your duct system, and I'll show you how it's done. So here you have a radial duct system, and here you have a bunch of inputs. Let's talk about our supply duct. All right, so you can, you know, specify where is the duct located, and is it a radial or trunk and branch? What's the configuration? Single, two-story, one trunk, two-story, one trunk small, or two-story, two trunk? What's the ceiling type? Especially if you are in an attic, you know the ceiling type. What's the duct R value in terms of, that would include any liner or insulation. The higher the R value, the better insulated it is. What's the duct leakage? So is it really sealed and tested? That means it's going to leak very little. Is it average, or is it unsealed? That means it's totally leaky. Let's do average. And then your floor area is calculated from the inputs before. And then what's your duct surface area? So if you erase that number to the display keyboard, it will automatically calculate your duct surface area, basically 18% of your floor area. Now this may be a bit large, so let's look at what's going on here. Let's go back. Let's click done. Let's see what our duct load is. So it looks like our duct load is about 20,000 BTU per hour. So that's almost like almost 2 tons. That's pretty significant. So I'd say let's go back. We may want to, let's change the duct surface area. Let's go down to 600. And let's see how it changes things. So now we're down to 10,000. It's a little more reasonable. But it is important to properly specify the type of duct system you have, because it will affect your load, both cooling and heating. Here, in this case, we have 16,000 EG per hour of duct heat loss. So if we go back in our duct system, now what about return air? If you don't have a return air system, you just enter like the number 1, and it's going to basically ignore it. All right, so that's it for the project portion. And you'll see down here we have some preliminary values that show our system load components, which include our ventilation, filtration, duct, etc. If we swipe again, you'll see kind of a more detailed breakdown of our cooling and heating loads, including percentages of each.
Sir?
And these are also in the, yes?
I didn't mean to interrupt, but I did have,
no problem.
I've been going over your program here. I watched another video before on it, and I have been confused about that. And I know there's no rules of thumb or anything like that, but that does make a huge difference on the actual ducts, the surface area.
Yeah.
Usually always 18% is going to give us something ridiculous, usually around here. We do, we just do a standard basic trunk line with branch runs, and usually a return is going to be about 15 or 20 feet of flex or something like that, Is there any advice you can give me for kind of a rule of thumb or something to make it a little more reasonable?
Are you talking about the area of the duct?
I know you said maybe cut it in half or something, but I'm just trying to get something I can be consistent with, that's kind of an average thing.
Yeah, I just noticed, like the ACCA Manual J8 handbook suggests 18% of your floor area, which, as you mentioned, and I know, I see it all the time, is way, way, way too high.
Yes.
So it seems like half of that is more reasonable, but, obviously it depends upon the type of house. Every house is different, right? So it really depends. But I would say, half to even maybe 30 to 40% of that 18%. So that would be more like maybe 6%, right? 6 or 7% of your floor area would be more reasonable.
In reality, what are they doing? Basically, if you had a typical 40-foot trunk line, are they just basically trying to get to how much surface area of ductwork you have? Some houses you might have 40 foot. Some houses you may have 20 foot of trunk line. Just kind of tweak it to how much length you have, correct?
Exactly. Because, surface area is your length times the circumference, or the, if you have square duct. If you have rectangular duct, it's length times the height and width of your duct times 2. So, you could kind of do the math. Yeah. If you know the different duct sizes, but if you want to do something quick and dirty, I would say maybe 7% of your floor area. But once again, that's really a rule of thumb.
I got you. And real quick, what was that equation you had for the round duct? It's length times circumference. Yeah, length times circumference of your duct. So circumference is 2 pi r, right? So if you know that, suppose your duct is, say, 8-inch diameter, so r is 4, so 2 pi is 8 times pi, which is around 24 inches, and then which is 2 feet. 2 feet times, say, 20 feet. 2 times 20 is 40 square feet. So that's just real round math. But 2 pi r. Okay. So that gives me a good idea. Okay, I get it. All right. Sorry to interrupt you there. Yeah, no problem. No, that's the purpose of this webinar, is to be interrupted. Don't worry about it. Okay. All right. So let's continue. We got about a half hour left. All right. So I've shown you the project inputs. Let's move on to envelope. So now that we've defined our basic project inputs, we want to start talking about defining our walls, our roofs, our floors, our ceilings. And remember, we're in the block load. So we're not looking at the room by room yet. We're looking at our whole house from the outside. All right. So here you're going to start entering all your envelope components. And, similar to your project
you click the plus button to add envelopes, and you can also copy existing envelopes. So suppose you have 4 walls that are similar, but they may be on different orientations, but in terms of the construction types, they're similar. You can copy those over and over again, and then just change the specific ones. Just for the sake of time, I'm going to select existing envelopes to look at. So here we have a west wall. So to determine what type of envelope it is, you have to select the envelope panel type. So click this, and you'll see that we have a number of different types of envelopes, whether it's a wood metal door, above grade wall, basement wall below grade, a partition wall, which is a wall that's adjacent to an unconditioned area like a garage, a ceiling, or a partition ceiling, which would be underneath an attic, and then floor. So remember, you ignore walls that are between 2 conditioned areas. So for example, if you have a living room wall that's adjacent to your kitchen, you're going to ignore that wall because the wall's not conducting any heat, so you don't worry about it. You only model walls that are either facing outside or walls that are adjacent to a garage or another unconditioned area. Okay, so for this wall, I can select my orientation. And this is obviously important, not so much for the wall itself, but for the windows on that wall. And when we go to the window tab, you'll see that you'll be able to assign windows to walls. And then once you assign them, then it will attach that orientation to that window. And that's where it's really important. Because obviously an east and west window, or a south window even, is going to conduct a lot more heat and solar radiation than a north-facing window. Because obviously the sun, rises in the east, sets in the west, and is more facing toward the south during the day. Your north windows don't conduct as much heat or solar radiation, so the load is a lot less. Unless, of course, you're in the southern hemisphere, then it's the total opposite. All right. So construction types. So this app includes a wide range of construction types for a wide range of different types of walls: frame walls, block walls, alternatives. So under my frame wall, I have a whole list here. And as I move through this list, you'll see that it displays the description in more detail here, and also the U values. And these numbers here all come from ACCA. So if you happen to have the ACCA Manual J8 handbook, you can look these up and see them, in the tables in that handbook. So I'll select one here, click done, and then it will automatically fill in my U value, which is 1 over my R value. And it will also automatically fill in what's called my cooling load temperature difference value, which is more of a solar type fenestration value. So if you're not sure what to do with these, just leave them because they were auto-filled in by your construction method. But as you can see, this is maroon. So that means you can also go in and override it. So if you definitely know what your U value is for your wall, then go ahead and do it. Override it. Also, if you happen to know what your CLTD value is, you can override it also. But in most cases, I would just leave it. Here you enter your wall width and your wall height. And it will multiply the two to get your total area, 440 square feet. Okay, let's look at the south wall. And let me change that to south. Same construction. Let's look at my east wall. Actually, let's change that to east. And then north wall. All right. So now we have 4 outdoor walls selected. Now let's go down and look at a vented attic. So my vented attic, I would define as a ceiling. Okay, it's facing northeast. And let's look at the construction. So here I have 3 different categories: under attic, roof deck, roof joist. So under attic, so here I can select a ceiling under an unvented attic, R13 insulation. So basically it's almost like a partition in this case. So what it's doing is it's assuming that my ceiling is pretty well insulated, but there's still going to be some heat transfer due to that attic above it. And that's what it takes into account here. Then I can enter my ceiling length and width. Let's look at a floor. And as you can see for floor, you have 4 different categories: over enclosed, over open crawl, basement, and slab on grade. Let's look at slab on grade. Select a concrete slab on grade. will autofill in my U value. And here, since this is a slab on grade, I need to enter the length of my exposed edge. And then, is there a radiant flow or not? It will affect your heating load. Front door,
Hey,
metal
I
door.
had another question.
Sure.
Back on the, let's say the floor or the ceiling, either one. If you change, I know the ceiling, the slab's different because it's a linear foot, but if you had the floor, and let's say you had a typical 1,500 square foot house, maybe a 50 by 30, just say example, to get it to 1,500 square feet. Is instead of trying to, because a lot of houses are cut up and you have to measure different dimensions to get your total square feet, is there a way, can you just put 1 foot by 1,500 foot to get 1,500
Absolutely.
instead of trying to do the math?
Yes. Yes.
Okay. Yeah. I was just wondering. That's good.
Yeah, because all the program cares about is the total, you know, the multiplying the two. So it doesn't matter how you enter it. The reason we do it that way is just some people like to be able to, you know, they know the length, they know the width. But yeah, you can do it the way you just mentioned.
Yeah, and a perfect square house, that'd be good, but if you have different pitch, you know, jet outs and things like that. Okay, thank you.
No problem. All right, and then a partition wall. So as I mentioned, a partition wall would be a wall inside your home, but it's adjacent to an unconditioned area. So here we select partition wall here. And then construction type would be similar to the construction categories for your above grade walls. And then it will autofill in your U value and your CLTD. Now in this case, CLTD doesn't really apply because it's indoor, so there's really no solar load. But it tilts it anyway. You enter the width and height, and then here you would enter the temperature on the other side of the wall. So this would be your temperature in the summer inside your garage, and this would be the temperature in the winter inside your garage. And it takes this, you know, subtracts out your set point, and it will calculate the heat loss across that wall in summer and winter. So the difference between a partition wall and an above grade wall is a partition wall has no solar load. Okay, so that's why the inputs are a bit different. All right, so we've talked about our envelope, and as you can see, you have the same pie chart as you did in the other screen, and you can also look at your breakdown here. All right, so let's move on. We have about 20 minutes left. Let's look at window. So windows obviously are your, you know, fenestration or your windows and your glass doors. And you can do the same thing as you did under envelope project. You can add as many windows as you want. You can copy from existing windows. So let's look at our west-facing window. So if you remember what I mentioned before is the way you set this up is you actually have to assign the window to a wall that you defined under your envelope. So in this case, attached to wall, and it will list all of the above grade walls that you entered or inputted under your envelope section. So here I'm going to select west wall. So what does that do? Well, it does two things. One is it makes sure that that window, you know, that the program knows that that window is facing west, so it takes that into account. And two, it also subtracts the area of your window from that wall, so it won't double count. Now, the construction of my window is either single, double, or triple pane. And the frame construction, is it you know, metal, wood, vinyl, or insulated fiberglass frame? Now, based upon these two inputs, it will auto-fill in your U value and also what's called your solar heat gain coefficient value. And these values actually appear on the stickers on any new Anderson windows or you know, any other windows that you may use. And this is basically the solar characteristics of that window. The window type, is it just a regular window, bay, or garden? If you're not sure, just do default. And then here you can enter the area. Suppose you have like 5 windows that are exactly the same on your west wall. You can just enter the area of one of those windows and then enter a quantity of 5. And once again, all it does is just multiply things out. So if you enter, you know, 14 here times 2, it's 28 square feet. Or if you just want to do 28 times 1, you can do that. Doesn't matter. So, you know, one thing about windows, you know, above and beyond your envelope is you need to take into account shading. So there's internal shading and there's external shading. So internal shading can be, you know, determined by blinds, shades or drapes. So you can select which type here. And you can enter what percentage of that window is covered by the blinds. In most cases, it'll be 100%. Also, if you happen to have an insect screen, that will affect things, whether it's external, internal. You can also enter characteristics of a window, glass door, sunscreen. So if there's no sunscreen, just enter 1. If there's different levels of sunscreen, select the appropriate one. And then you would enter the coefficient for that and also the percentage of that window that is covered by that sunscreen. Exterior shading. So this ground reflective. So, the ground actually reflects the sunlight onto the building. And depending upon what makes up that ground, it will reflect in different ways. So green grass may absorb that sun a little greater than, say, tar and concrete, tar and gravel or asphalt. That may reflect the sun more onto your building. So it'll affect your load a little bit. You can also enter external shading devices. So suppose you have an overhang. You can enter the characteristics of an overhang. So first you need to enter how high your window is, the length of that overhang, and how high above that overhang, or how high that overhang is above your window. And it will do all the geometry and to determine what percentage of the window is being shaded by that overhang. So based upon all these parameters, your external shading, your internal shading, your sunscreen, it will calculate your window load for both summer and winter. So same thing with the south. I assigned it to the south wall, east wall, and then north. And you'll notice my north cooling load is 192. Meanwhile, my south is 310. So you'll see, obviously, the south facing is greater than the north facing. You can also model glass doors here, not just windows. All right, let's look at the final tab here, the skylight. So skylight is just a horizontal window on your roof, say above your kitchen or your living room. You can add as many as you want, similar to the other sections. And here, the inputs are a little similar to your window, but in this case, you're going to select the roof or the ceiling that you want that skylight located on, which you defined under your envelope section. Then you enter the construction number. Is it a single, double, or triple pane skylight? And also the current construction. Based upon these parameters, will autofill in your U value and your SHGC value, which you can override. Then you enter the area of one of the skylights and the quantity. And once again, it just multiplies these two numbers. Now, we don't take into account shading for skylights just because ACCA does not require it, and it seemed like overkill. So there are no inputs for shading. And here's your load in summer and winter due to that skylight. All right, so we've defined all the parameters that we need to for our block load. And as you can see, our total load for cooling is around 5 tons, over 5 tons, 2,500 CFM, and for heating, about 102,000 BTU per hour. So let's look at some reports. All right, so to get to the reports, you click the little pie chart icon, and you can see there's 4 different options here. System reports. So these are the reports that allow you to view all of the information that you've entered, or the results. So here, you have your demographic information. Here's a load summary. If you swipe, you'll see kind of a checksum values, kind of like rule of thumb values that are calculated. Swipe again, you'll see a breakdown of your cooling and heating loads, which we've seen on the screen before. Swipe again, here's your room by room breakdown, which I have not shown you yet, but I will. Swipe again, you see your pie charts. Now, the nice thing about this is you can print by clicking this little print icon, and you can also email by clicking the email button here. And it will email these reports as PDFs. So it will open your email program, you type in the email address, click send, and it will send you PDFs of all these reports. All right, let's go back. Let's look at room reports. So as I mentioned, we haven't talked about the room by room yet, which I will. And so I will come back to this after I talk about the room by room. HTML report. Now, This won't display on my emulator because the emulator does not email. But what it would display is your email program, and it will actually fill in almost a table with all of your outputs. And it also includes a little spreadsheet. So you can email it to yourself and open it in Excel. And then the final option here is email database. Now what this is, we find this very useful, is someone will call us up and say, hey, my load doesn't look right, or something doesn't look right. My airflows are too low, or my lows are too high. And obviously, without looking at what they've entered, it's impossible to diagnose. So what we do is you click email database, and they can actually email us their database. We open it on our app, and we can view exactly the project that they are working with and help find out what the issue is. And this is useful also for you, is suppose you have multiple iPads and you want to share projects with one another. You can do that. Now, mind you, make sure that you don't, because what this will do is when you email to someone and you open it, it will overwrite their projects on their iPad. So if you don't want to overwrite each other's projects, then don't use this function. This is only for if you want to share projects and you don't mind overriding your own projects. All right, so let's continue. Let's talk about these buttons a little bit up here real quick. This calculator icon, it just performs additional calculations, especially for the AED curve. So if you see that the AED curve is not displaying, or if you see that this pie chart is just one color, so click the little calculator icon and it'll perform all the calcs. The I button, this is kind of your settings form. And this allows you, suppose you're working in Mexico or maybe up in Canada, Quebec or whatever, and you have to work with metric units, you can work with metric. Down here, you can actually change your max values. So some people get confused and think these are actual inputs into your project. They are not. 99% of the time, you're going to leave these values the way they are. But suppose you want to increase your maximum floor area from 10,000 to 20,000 or to 50,000. Well, you just go in here, click done, and you'll see now that my max floor is 50,000. So all it does is changes your max values on your slider controls. That's what these values do here. And if you keep scrolling down, you can change your company contact information, and this information shows up on your reports. Also here, your unit, occupant, sensible, and latent loads. So if you remember, we entered the number of people. Well, basically, it multiplies for sensible, the number of people times 230, and for latent, the number of people times 200. If you want to change these values, suppose people are more active, you can increase these sensible and latent loads. All right, so we've kind of covered the block load portion of this app, and let's move on to the room by room. And I'll go through this fairly quickly. So the room by room, as I mentioned before, allows you to start defining the individual rooms in your home. So you can calculate airflows and as a result, size your ductwork. So, in most cases, you can't just start with the room by room if you create a new project, because the room by room will use the constructions that you've defined in your block load section. So you do need to always do a block load first and then do your room by room. And I'll show you how that works. So here we have a room list similar to our, project list here. And you can add new rooms with the plus button. You could copy from existing rooms. So suppose you have say 2 or 3 bedrooms that are on the same orientation or, similar areas. You can copy those and then just change the information for that specific bedroom. All right, so I'm going to work with existing rooms here. Here we have an office. Okay, I can enter the number of occupants. So suppose I want to have a sensible and latent load for my people. Then also, if you remember in the block load how we defined our appliances, well, now we can start assigning individual appliances to individual rooms. So in this case, if I click the caret icon, I can say, hey, you know what? I have 1 television in my office. I'm going to click the number 1, enter the number 1, and then go back. And you'll now see that it applies that television load to my office. And if I want to go back and I say, hey, actually I have a computer also. So this is a great way to be able to allocate all your appliances across the different rooms. And you'll see for the room here, I have my pie chart and my breakdown for the individual room, both cooling, heating, and you'll see there's no AED curve. If I click the calculator icon, it now calculates my load profile. And you'll see it's a lot different than my block load profile, isn't it? Look at how different it is. So the reason is because, you know, the rooms are at different orientations throughout your home. So the profiles are going to vary, especially if you have a room that's facing north versus a room that's facing south. So this tells me that actually my peak load is at 9 a.m. in the morning, and then it gradually gets lower. So probably, most likely, I have east-facing windows in this room because as the sun rises, it's contributing to that solar load in the morning, but then as the sun sets in the west, I don't have that solar load anymore. So let's move on to the envelope. So here, I can start adding envelope items, whether it's a floor, a ceiling, a wall, etc. Now, let's look at a west wall here. And what you see is when I add a wall to a room, I can actually select the wall that I define in my block load. So you'll see all the walls that I define, or actually all the envelopes that I defined in my block load are listed here. So I can say, hey, you know what? I want to get the construction of the west wall that I defined under my block load. And it will show me how much area is remaining. So if you remember from my west wall here, I entered an area of 850 square feet. So as I'm starting to enter input areas for the individual walls for each room, it will subtract this out. So for example, let me enter the value of 300. It's done. And you'll see now there's 360 square feet left because I've entered west wall for probably another room. And you can actually go above this. So if this number gets negative, it's not a big deal. Because all this is just showing you, giving you a reference. So this is why there's a relationship between the block load and the room by room. And it's important to first define your block load and enter all the information, and then do your room by room. So here's the load for my west wall, cooling and heating. Here's my north wall. Floor. So as you see, I selected the passive slab, which I can find under my block load in the area, and then ceiling. Same thing with windows. So I can add new windows or copy from existing, and then when I add a new window, I select one of the windows that I created in the block load portion of the app. So in this case, I selected the north-facing window, and for my west window, I selected the west-facing window. And then enter the area of that specific window that's in that room. Skylight, well, there's no skylights in this office, so there's nothing there. So you see what I'm doing here is I'm adding individual components for envelope, and I'm just deriving the construction characteristics that I inputted under my block load section. Same thing with my window. So here's my total block cooling load. It's actually pretty high for a room. Probably I've entered some unrealistic numbers, but anyway, this shows you my total cooling and total heating values. Let's look at bedroom 1. Same thing. I have a south wall, west wall, floor, ceiling. I have a west window and a south window, no skylight. Now I just have one occupant. I have no appliance loads. And here's my total. Oh, actually, that's my total block load. Here's my total room load. That's more reasonable. 5,000 BTU per hour cooling, 10,000 BTU per hour heating. Let's look at kitchen. Put appliance, and let's add a dishwasher. My kitchen. We have an east wall here. And we have 2 south walls and 2 east walls. And then the skylight. So my total load for my kitchen is 7,800 BTU per hour cooling and 15,000 BTU per hour heating. So one thing you'll notice is the total of all your room loads will never equal your block load. If it does, it's a coincidence. And the reason is for a couple reasons. One is, you're not going to model your hallways, and that includes some square footage, right? But you don't really model that in terms of flooring. I mean, you may want to, but most of the time you're not. And so, the total area of all your rooms will probably not equal the total area of your home. That's one reason. The second reason is, your rooms peak at different times during the day. So as you add up all your rooms, most likely the cooling load is going to be greater than your block load, called the sum of the peaks. While your block load is just one peak. Calculates, that peak cooling load during the day, which is usually in the late afternoon. So the sum of your cooling loads and heating loads for your rooms will never equal your block load. We get calls about that at least once a month. Why does some of my room loads not equal my block load? Well, it's not supposed to. It never will. If it does, it's coincidence. So that's kind of how it works. So let's look at the reporting. So if you remember, I showed you room reports. So now we can actually go into each individual room and display a pie chart report. And once again, email it or print it. You can also go into my system reports. And if we swipe, you'll see this report shows me a list of all my rooms, my cooling load, my heating load, my airflow. And this is a nice report, especially if you want to start sizing ductwork. All right. So that's kind of a quick overview of the app. There's, more to it. And if you want more information, you can always go to the help. The help is actually quite extensive. You click the little help button here, and it actually goes to the help on our website. And there's a lot of information on help. Also, we literally have probably 20 training videos that we've conducted over the past 8 years for this app, since about, I think, 2012, 2013, so 7 to 8 years. So a lot of training videos. Also, just call us if you have questions. We'll help you answer them. And one other thing I want to make you aware of is the equipment locator, which is a whole other app. This app is actually embedded in all of our apps. And this allows you to actually enter information about your equipment. And you can sign in, store the equipment in the cloud. You can view it on the web. So it's a great way to enter information about HVAC equipment and take pictures, upload photos, and just keep track of all the information that, maintenance information. You can also share with other technicians in the company. So that app is actually embedded in this app, and it's embedded in all of our apps. But that's a whole nother webinar. All right, so before I end things, are there any questions?
Yeah, just a couple quick ones.
Sure.
I did notice on the when it has on your reports, does the I noticed it had the tonnage on there, and sometimes even around here our local, like our E-Score program, they'll allow you some variance in your load to multiply it by 20% or something. You fall between that range. Sometimes it may go up or down the unit. Is there a way not, because I just didn't want if we sent this to a customer, I didn't want them to be just focused, like in your example, it said 5.5 tons. And if I sold them a 5-ton, they'll be like, well, your load says it should be 5.5. Is that something that you guys ever have problems with, or is that always going to be on there, the tonnage?
Well, I mean, we've never had a request to take it off. So, yeah. I mean, if you're going to, one thing you could do is if you're going to send one to your customer, you can always create a copy of that project and then lower some of the numbers to below the 5 tons so they're happy with it. But we've never had a request.
Yeah, and in fact, your example is perfect right here, 5.5 tons. Of course, there's not a 5. You really have to go 5 or up to a commercial system. So if you sent that to me, I'd be like, well, why are you selling me a 5 if it says 5.5 on here? But I just know how customers work.
Yeah.
So I get that.
I understand.
Okay. And then last, I have one other thing I was going to ask you about on your, and this is probably obvious, but on your additional, on your, like say your floors, if you had half of it was over, a crawl space and then half was over a garage, you can break up and put 2 floors on there with different square footage.
Yes, you can.
Yep. Okay, perfect.
Absolutely.
And then last last but not least, the burner input. You didn't go over that, but you just usually like to keep that at 1,000, even if it's a heat pump or a furnace. Would you keep that at around 1,000?
Yeah, I mean, truthfully, I don't even think this input is used. I mean, I know ACCA has it as part of their requirements, but I don't even think it's used. I mean, and maybe used in certain cases, but
yeah,
when I change that value, it doesn't seem to affect the heating load too much. So I wouldn't worry about it too much.
And same with the blower heat gain. Would you keep it on yes or no?
Well, that you'll see it does. It actually increases your value here by 700. So if you have no, you'll see now we're actually 1,400. We're at 13,586. But yes, it just adds 1,400. That's all it does.
Okay, and obviously everything's going to have a blower, so it's going to gain some heat probably. So I just keep it on yes. Okay, well that's it for me.
Okay, great. Well, hey, I appreciate you attending, and hopefully you got some good, good training out of this. I'm going to post this on our website within the next week or so. I'll send you. Let's see. Do I have your email? Yeah, I think I have your emails. So you got our newsletter, right? Is that how you heard about this webinar?
Yes.
Great. So I have your email, so I will send you an email when that's up. So if you want to go back and view things, you can do that.
Okay. Thank you very much.
Okay. Have a great day. Thanks.
Okay. Thank you. Bye.
Bye.